Hello, everybody. Welcome into the lab. Welcome, friends. Welcome. Hello, everybody. Welcome in. Welcome in. Give me 1 second here, and we'll get this dog and pony show on the road, y'all. Give me a minute. I need to do some sharing here really quickly. You know what I mean, Jelly Bean? One second, guys. I'll be with you guys in just a second. Just doing a couple things here real quick. All right, chat. Let's go. Baby, 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 baby. All right, guys. All right. Okay, everybody, welcome in, welcome in. Welcome in, welcome in, welcome in, everybody. My name is Red. This is the Red Row stream. Well, this is ARO, electronics, excuse me. And I need to get something out of my electronics bag here. So give me a second here. This is my travel bag for different stuff, different electronics things that I have. Meter 1. My ESR meter here. If you guys don't know what that is, that's for insert capacitor tester. If you're not familiar, that's what she is. Some of my favorite tools that I like to have out and about, you know. We got the voltmeter up here. That's my big voltmeter. And then this is my favorite kit. I love this. It's got everything in there. Guys, if you get a chance, go check out ifixit.com. And this is the Manta series of different crazy bits that are out there, you know, different setups and stuff like that. This set is fantastic. I think it was like 100, I think. Roughly $100. I mean, it's my favorite. I love it. It's like my favorite tool. You know, big handle, small handle, whatever you prefer, big or little. I like that it's magnetic. Boom. What else is in here? Oh, and I got, this is a inline XLR by different connectors, continuity checker, tester, you know, between, you know, beep sequences and stuff like that, from DIN plugs to XLRs to speak-ons to British Naval connectors or BNC, 1/4 TRS cables, and then the 8P speaker continuity tester and what have you. So pretty cool. Just a couple testers that I have. We won't need this, so we'll put this one back in the bag. I actually travel to work at a friend of mine's electronics repair shop. And I had to take a little hiatus there for a bit there because we were doing, I had some stuff that I had to take care of, and I'm on call for my job, my regular day job. So we're going to get this dog and pony show on the road. Yes, I wear rubber gloves. Why do I wear rubber gloves? First and foremost, I wear rubber gloves because I hold solder in my hands, leaded and unleaded solder. So I wear gloves. It's just something that I just got used to over time. So what's going on with this? So what's happening with this is it's going into protect mode. It's to the point now where you can't plug it in. I plugged it into a tester, a Varactor which you basically bring up the voltage on the plug. You usually use it for tube type stuff, but I use it for solid state stuff like this, or anything you can plug in. You use a variactor for turning things up, the mains in coming into to any particular unit, because you never plug something in without looking at it, first and foremost. So that's one of the things that, like, I always tell some people that want to get into doing electronics repair is don't plug something in, because you don't know what's actually happening with it. And the worst thing you can do is plug something in and you further damage a customer's device. And we don't want that, right? So what I'm going to do here is I'm going to isolate the main power supply, which is here. Obviously, this is a transformer. If you're not familiar with what a transformer does, it transduces alternating current and steps it down into DC, essentially. And then what happens is it gets carried through, this is a bridge rectifier, parallel bridge rectifiers for a full wave rectification. And then once it goes through there, it's now quote unquote direct current, or DC at that point. And then once it makes its way into the coupling area, it comes in, it drops into the filtering network, which is here. Okay, your filtering network is here. Okay, give me my pointer. Where's my pointer at? This is my little pointer. So in here is where you have you can't even see that, Angelo. Yeah! Bloody hell. So in here is filter capacitors. And then it comes out of the filtering caps and it gets introduced into the main logic board. Well, it's already introduced. It goes down into the main logic board. And I think this is an LM something for the protection diode circuit, which is here. Yes, that's an LM3542 or 3245, whatever the case is. So this is the protection area of the circuit board. And then once it comes out of there, it comes up and it goes out to the variable. Ow, motherfucker! Ooh, that's supposed to be the other way, dummy. Mercy sakes, that hurt. Sorry, guys, for screaming in your ear. I got my new soldering station. We'll talk about that in just a second. So it comes out and from the varying the voltage variation, which I'm going to change these colors on this to here. I'm going to change them out. I don't like that they're green, and so is the protection diode circuit, which is coupled into the HL8S22F, which is a 12-volt DC regulator. I mean a relay circuit. Here, pulled up by a two pair diodes that are they're coupled together, and then the voltages drop down and it goes into the regulator, which is over here for your pass transistors. From here into these stepping resistors into a voltage control variations of voltage control that gets stepped into the sensing or the collector side of the pass transistors that are on the back. So one of the things that I always like to do when I run into this problem where the unit is unresponsive, so to speak. So one of the things that I do is I'm going to isolate these. I'm going to connect these two together in just a moment. And then what I'm going to do is I'm going to isolate I'm going to put these two together, get the mains running on the transformer. I'm going to pull the rectifying circuit out of the way, okay, completely. I'm gonna take it out of the way, and then if it still holds down, like if it still pulls down on the circuit and it trips, I have a bar that's here, which is my circuit board bar. and that basically will click off and it'll tell me, hey, red, this is no good. You have to, or what? Yeah, you have to stop here. This is the problem. I don't think it's the transformer. I think it's either going to be the bridge rectifying circuits that are in parallel here or the pass transistors that are on the back. The main board on these doesn't really go bad. I don't see anything blown or swelled up and what have you. So that's where we're going to start. Again, thank you guys and gals for coming in. We're going to put this little meter on diode mode. Thank you, everybody, for coming in. I appreciate you. Of course, this is unpowered. We have the meter off. Okay. All right, we're in diode mode. Okay. So the first thing that I want to do is I should take these rectifiers out, but I'm just going to poke around here and see what we got. I am going to poke around here. I like to take off all the zip ties. It doesn't, it allows me to move the wires around and what have you. And, go from there. This is a fan, if I'm not mistaken. I don't need this there at the moment. Actually, that tied into that? What the hell is that? Okay. Interesting. No, well, there's the problem. Look at that. That wasn't even connected. Huh. That wasn't even connected, y'all. You believe it? Part of the bridge rectifying circuit was not even connected there. How about that? And one of the things I do is because I'm a very anal retentive. Is I mark the components. I'll mark them. 1, 2, 3, 2, 4. I need my other marker. That wasn't even connected. You believe that? Make that 2. 1, 2. Okay. That's going to be 3. I just put lines on them. 1, 2, 3. 1, 2, 3. That's 2, 2. I don't know where the lid went. Okay. And we're going to give these a look. We're going to test these out. see what we get here. Put it in diode mode. Okay. Okay, so there's the problem there. We have 0.8 on that side. Now I know I'm only using 1/2 of this, so we should still have something there. Not just on 1/2. Point 0.8 there. But nothing on this side. Very interesting. Okay. Okie dokie. So that's going to be where's my marker? Two. That's going to be 3. All right. Now what I want to do is plug this bad boy in. And it's 2. Plug it in and see if the power supply holds down the circuit. It's 2. Two, 1. That's 1. Okay, so always be mindful of your mains in. Make sure that they're isolated, and you're not fucking hurting yourself. Make sure you don't touch nothing. So this is what I like to do. And they have caps on them, so I'm not really worried about it at the moment. Let's give this a power on. I have to jump that out. And if it holds it down, then I know it's the supply. Let's take a listen. Okay. So the protector's on, which is right. Well, that's a good. That means we don't have any malfunctions with that. So what I want to do now is go into voltage mode. Now that we have it powered. And we're going to go alternating current. And I'm going to go through the post in the front here for ground. $19 volts. Good, good, good. Beautiful. 19 volts all day. 19 volts. That's a beautiful thing. That's all I wanted to see. Okay. So I'm going to check these other rectifiers and see where we go from there. So we can turn this off, unplug it. That tells me a lot of different things. That everything is copacetic, as they say. So that tells me we're looking at these bridge rectifiers that are here. All right. So what I like to do is go back to diode mode. What's going on here? Microphone got tangled. I wish I knew what the model of these rectifiers were. Okay. Don't make a lot of sense because got nothing there. Nothing there. 0.8 there. And we should have 0.8 here. Nothing there. Nothing there. 0.8 there. Okay, well, they check out. So that leads me to believe at this point that it could possibly, very well may be, that my next thing, I'm going to reconnect all these again, right? Where I'm powered. Okay, so this is one. So we know the transformer is good at this moment. There's no problems with that, right? We know that's good. Ooh. That's good there. Okay. We need 2. 2 goes back down around yonder here. Okay, and we're going to need number 3. Where's number 3? This is 3, but what I'm going to do at 3, I'm going to leave 3 off, and then I'm going to check the rectifier, because this is the main in, this wire here that comes in, it goes to the circuit board, so I'm going to leave this out, and then if it holds down the circuit, then I know that it's the back bridge rectifier. This one is 3. 1, 2, 3. We're going to leave that out. That goes to there. This is 2. And we're going to leave that out. Okay, those 2 out of the way. This one is 4. 1, 2, 3, 4. That goes here. No. This one's 3. 1, 2, 3 lines. 3 lines. Okay. Okay. All right. So our main ends are here and here for each rectifying side. So both negative and positive going. So the one thing, and we do have power present here. I don't want you to forget that. So I have bare leads here. So what I'm going to do is grab me a little tape here. I thought I had a roll of tape here. Oh, there it is. Okay. And I'm going to cover these because they may have some voltage present. And we don't want them touching and hitting the chassis. Just a process of elimination, you know. Make sure that they're on there good. Beautiful. I'll even loop them back once. Like that, so they don't bump into each other. So now what we're going to do, we're going to power this back on and see if we still have the fault error, which we should. Ha ha! Okay. The one that I suspect is this one. So we're going to take this off. That off. And this one off. Okay. So I think my assumption is going to be right here. And it's the bridge rectifiers. It should be clean and green now. All right, so bridge rectifiers is what it is. But I am going to go forward and check the pass transistors on this as well before we make our decision on if that's going to be the problem or not. But while this is beeping away, I want to continue on because we do have voltage present on this board, if I'm not mistaken. So that's what we're going to do at the moment. We're going to take a look here at that. Give me 1 second, guys. I have to check something. I have to actually stand up and stretch my legs. Give me 1 second. All right, I'm back. I can't believe nobody's come in to check me out yet. Bum, 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 bum. Alrighty. That's my nicotine chap. My teen of nicotine. Okay. So back to what I was doing. We're going to do this one more time. I'm going to check some voltages. Hope you don't mind the beeping. Okay. I need to check that regulator in the back there. Put that on diode mode. All right. So, all right. I need to check these pass transistors. Good. Okay, we have a short. Yep, there's our problem, y'all. We got a short in the pass transistor. Well, maybe not. Oh, it's acting funny. It's not like these other ones where I put it on there and it's good to go. But we're going to reverse it and see. Because we got 0.6. 0.6. And this guy. Nah. All right. Cool. We need to replace the pass transistor. It takes a while for it to build up. We're getting a reading, but it's really goofy. All right. Let's flip them the other way and take a look. In a book. It's really odd that they all went bad like that. Okay. In a book, take a look. In a book. Bum, 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 bum. What is going on here? This is like balled up. Like, what in the hell is going on here? What's going on here? Yeah. Get that out of the way. Okay. All right. I'm gonna do one more thing. Don't come off of there, Red. I want to take off these screws and flip the board over to see if there's anything fucked up. I'm looking for the other screwdriver. All right, let me turn this on here real quick. Okay. What the fuck is going on under here? Wow. Holy piss. I've never seen such botchery in my life. Look how shitty the solder job is on this, y'all. Wow. Looks like somebody's already been in here. Let me show you this. Can you explain that to me? How crappy that is. That's terrible. What is that? That's like, looks like some kind of a liquid or something hit that. What the fuck is that? I've never seen anything like that. That doesn't even look right. Let me put you guys back up here. I've never seen anything like that. Well, we're gonna fix it, that's for sure. Or clean it anyway, for that matter. All right. Shit. I need cleaner. Oh, I have it here. There's a slice across the trace. I don't know if that's supposed to be like that. This is my my cleaning pen. There's like, it's not even attached. It's like nothing is attached to it. You can see the cut in the trace. Well, that ain't supposed to be like that. I know that for a fact. Where's my flux? Flux, flux, flux. You crazy flucker. Excuse me. Okay, now I see what's going on here. Yeah, that was like a cut or something that went across the trace. Maybe somebody tried repairing this prior and didn't realize that there was a cut across the traces. Could very well happen, chat. What we're going to do, we're going to reflow this again. Just a second here. Some more flux here. I love this new soldering station I bought. It's fantastic. That's why it always pays, guys, to double check something that you're working on. You know, because you never know what could happen. You don't know who's been in here. You know, you just don't know. And then I'll reflow this with some low melt solder. I mean, I really don't like it. What? Oh, stop it. Don't be a bitch. I don't really like the idea of it being all this like blobby and nasty looking. It's me. I'm thinking about just resoldering the whole thing, to be honest. We got some traces here that are close to one another, and I don't want to. Give me 1 second, guys. I have to fix something here. Pissing me off. Sorry about that. Sorry about that. Sorry about that. All right, we're back in action. Yeah, I love this new soldering tool. My new soldering station. It's fucking fantastic. Yeah, bring you guys. That don't matter. That fucking hurt. All right, I fixed that. Now, I don't know if that's supposed to be there or what. So we're going to remove that. Because I don't know if that's right. Yep, that goes there. Always double and triple check your work too while you're doing such things. All right, well, they fixed that. We're going to screw this back down. And then maybe we'll power it on and see where it takes us. All right. I have an itch in my eye. I need an eye loop. Eye loop, eye loop, eye loop. check this really quick. It's a little too close for me. A little too close for comfort. Oops. All right. All right, so what I'm going to do now is I'm going to screw this board back down again and see what we got going on here. See that? Fucking gloves are a pain in the ass. There's no powder in them. All right. Somebody's riding a motorcycle. All righty. No. Right here. Yo, what's up, Mark? I ain't nobody's dad, but close enough. What's going on, man? I'm gonna start streaming ATS around 6:30. I mean Farm Sim or whatever you want to play. All right, what we're gonna do? We're gonna screw this sucker back down again. We'll screw her down. And go from there. Excuse me. Yeah, there's a big slash across the board on the bottom, so maybe that did it. I don't know. Let's see if it fixed it. I don't know if it did or not, but you can't have a cut trace on a board or else nothing will work. And it was right down there by the pass transistors, so I'm thinking that That's what the problem was. What's going on with you, Mr. McCluskey? All right, sounds good. We'll do trucking. All right, I think everything's connected here. All right, give me a second here. I'm going to try this. If this don't work, then I am going to take a break and go from there.